Hello, calculus fans. Let's take this series where we're going to sum 4n squared plus n all over the cube root of n to the 7th plus n cubed. We'd like to determine if this series converges. Now, the behavior of this series is really based on the highest powers in both the numerator and the denominator. So we're going to make a comparison, really a limit comparison, with the series where the terms are 4n squared over the cube root of n to the 7th. I'm essentially looking at the highest order terms. Now this series is the same as the sum of n squared over n to the 7/3. I've pulled the 4 out, which we can rewrite as the sum of 1 over n to the 1/3. That diverges by the p-series test. The p in question is 1/3, which is less than or equal to 1. So let's let a sub n be equal to the terms of the original series, and b sub n be equal to the terms of our compared series that we know diverges. We're going to do a limit of the quotient of these terms. Now we clean this up so that we end up with a limit as n goes to infinity of 4n squared plus n over 4n squared times the cube root of n to the 7th over the cube root of n to the 7th plus n cubed. We have a limit of a product. This is the same thing as the product of the limit, provided that both limits exist, and in this case they will. In the first limit, we divide top and bottom by n squared, so that we get limit of 4 plus 1 over n all over 4. And in the second one, we end up dividing top and bottom by the cube root of n to the 7th. We're just trying to get rid of that highest order term. And both limits come out to 1, because you should be able to see that these little pieces here, they end up going to 0, and so the only thing that's left is going to be 1. And therefore we can say that the original series diverges by the limit comparison test. Why does it diverge? Because we're making a comparison with a divergent series. Okay, that's all for now.